So basically this sales representative, he will be creating a sales order and the product will get sold to this customer. And a sales order is copy. A sales order in sense it's actually order fulfillment. It's a cycle, okay? Hello? Yeah. It's a order fulfillment. It's a process. But let's consider like a small segment. A sales order will get created and that sales order will get loaded into the sales table. Now, as you know, my warehouse is got emptied, right? So I need to get some more products into my warehouse. So only I can satisfy the upcoming customers. So I'll be generating a request to my production and planning department, and they will do some plan, and then they will start at some production, and they will be generating certain production orders. But to start the production, basically I need to have a raw materials to do it, and I should have a plant and all. Okay, in that case, let's assume I don't have any raw materials, so I'll be requesting to inventory. From this inventory, the request will pass on to purchasing, since my company doesn't have a raw material. And purchasing division will be releasing a purchase order to the vendor. And vendor releases the raw materials that will back to this, and into the manufacturing. And then we will do the manufacturing. And first of all, I need to make sure the quality of the product is good. So the quality management will go with the QA and QC, and the product's quality will get assured. Then I need to fix a price for this. And basically, price is it's a formula, right? Cost plus profit. Let's consider it as in terms of simple. So it's cost plus profit. So the product costing division will be finding a cost for this. Then the sales and SD department will do the pricing of it. Then it will be shifting the product into the warehouse. Now, you understand the process, right? Mayur, you got that idea, right?
Yes.
All right. Now, we got a problem in this one. After this sales order took place, after we sold this product, and my warehouse got emptied, now I had a situation where I needed to get that product as fast as I can. So I send the request to production, and production department send the request to this inventory, to this purchasing division, and the purchasing wanted to make the purchase of a raw material called X. Here, what I am really facing is I have 100 vendors who can supply this material X. Okay, now to which vendor should I give this order to? How do I figure out? Mayur?
Yes.
I told you I have a X and I have a V1 vendor V1 to V100.
Okay.
To which vendor should I give this order to? How do I find the best vendor for this material, or based on what criteria should I consider this? Should I choose the vendor?
Who will supply the goods uh, fast?
Goods as fast as they can, right?
Yeah, as fast as they can.
Exactly. But how do I find a or
Maybe
Not
with
base?
the past information what we record in our system.
Exactly. So we need to search in our historical data, right? So I decided to take a search on this table. Okay, but the problem is this table is holding hundreds of millions of records. If I do a search now at 10 o'clock, 10 a.m., that query is going to run for another 10 or 12 hours, and I will be getting the result only after 12 hours. That's my one problem. Now let's assume that this search, that analytical search has taken place at 10 a.m. and at 11 a.m. let's consider it like a very simple machine, okay? At 11 a.m., if somebody tried to create another purchase order for the same company, what will happen to that purchase order? Let's assume at 11 o'clock, another purchasing employee is trying to create a purchase order. And will that order get created, or will that order need to wait until this search finishes? What will
so.
happen?
So that order will be in pending status, I guess, till the search is complete.
Yeah, but we have some temporary solutions. Okay, SAP systems like SAP, they will be storing those information on a temporary tables and all. But let's take the ideal situation where that order needs to wait until the search get finished, right? Because we have a concept called deadlock. Read and write cannot be done simultaneously on a table, on the same table, because the first operation will be keeping a lock on that system. Okay, so basically we are disturbing this machine, right?
Right.
Okay. Now, what is a very good solution for this? Two problems I have. I am disturbing this machine. Second one, if search takes 10 hours, 12 hours, or 1 day, 2 day, basically I mean, that's too delayed because I need to get the material as fast as I can in this situation. So what is an ideal solution for this?
If it is Oracle, what
Maybe
I will
we
do is
can
I will create a materialist view and use it.
You'll be creating what?
If it is Oracle, I will create a materialist view.
Okay.
So the
Uh,
materialist view will not have any deadlock, anything. It's also act like a table. I can insert and I can also know what you call. I can schedule the event for to propagate into other tables.
yeah, so it's kind of a duplicating.
Materialist view is temporary table again, so you can
Yeah. Uh,
what you call it's a view, but it's physical. Tomorrow, if you don't want, you can delete it and recreate it.
yeah, you mean index view, right? In SQL, we call index view.
Oh, it
In
depends. Okay, yeah, it's similar to that.
Oh, okay. Yeah. Okay. That's one kind of solution, but let's go for a permanent solution. Now, the best way, as he say, a materialist view is kind of a result set. Okay, a result set which will be stored in a separate table where you can run queries against it. Basically, view is a semantic idea, right? It doesn't store any data. It's just a script. But a materialized view will be running that script and it will be storing the results set in a temporary table.
Correct.
Let's go for a large scale, very long-term solution. Now,
probably
this is
doing.
that's sorry.
Yeah, sorry. Yeah, what I'm thinking, doing partitioning. If that, I mean, if that particular table holds very large data set, so how about doing a partitioning and storing the data based on the condition, might be based on the year or based on the product.
But still, we don't have any guarantee, right? Let's assume that table has got partitioned in 10 pieces, and most of the queries are running on the historical, 9 historical pieces. The latest one we don't touch. Let's assume it. 99% it won't. But in case if something comes to get the record from that 10th piece, 10th partitioned piece, where we need to do an analysis, and that's where the latest record is going to get loaded, right?
Yeah.
We don't have any guarantee. We need a permanent solution. That's where they come up with this idea. It's called data warehousing.
Okay.
Take all the records from the ERP, not all, necessity. Okay, necessary data. Let's assume we have that purchasing data here. Let's say this is my purchasing data. And I will be taking a copy of this purchasing data using this ETL. It's called extraction, transformation, and load, or ELT, extract, load, and transform. Then we will bring that data into, oh, and we will bring that data into a separate system, a copy of them. Okay. But imagine I brought that data into a separate data warehousing, and if when I ran that query against this table, it took 12 hours. What will happen if I run the same query against this? Will it take 12 hours or will it take less than 12 hours?
Probably it should be less time because it's going to be data warehouse. It will be in denormalized state. Also, we'll create some kind of dimensions, which
Yeah,
should be very faster for.
right. Okay. That's what data warehousing is. But let's consider this has been loaded into as it is, as like a copy of this table. So naturally, it will be taking the same time, right? In that scenario.
Right.
Yeah. So we need to have a fast architecture, very fast architecture in here. Let's assume this data warehousing is just a database. And we know database is like this. A DB layer will be there. And then we will have a front end, right? Now, I need your help with this, Mayur. This is a software idea, right? This is a database. This is a front end, like a studio. This is a software idea. Now, in case if I convert them into hardware, what would be the equivalent of this database piece? Mayur? Hello?
Yes.
Yeah.
Hello.
Yeah. Can you hear me?
Yes, I can hear you.
I asked. Now, this is a database and this is its front end studio. This is a software, right? This is basically a software, right?
Right.
If I convert this software into hardware, not converting, just interpreting the software into hardware, then what would be the equivalent of this DB area? Hard disk, right?
Yeah, hard is correct.
Okay, so I got a hard disk here. Now, front end means, let's say it's just a user interface or monitor or keyboard or whatever. Let's assume it. Now, in this database, we have a certain idea called, we need a piece like this. And we have a magnetic tapes. This hard disk is completely filled, piled up with the magnetic tapes. Let's take only one magnetic tape. And if you take one magnetic tape, it will be having certain pieces like this. It's called sectors. And the sectors are comprised of arrays, cell cities. So in database, if I say I have a data here, and that data is this employee, uh, a salary, and if I have a data like E01, $1,000, and that data will get stored here. Like the first cell will get occupied with the E01, the second cell will get occupied with the 1,000. That's how it will occupy. Now, this is not the problem. The real problem is, let's say I have a business intelligence layer, like a analytic tool here. And if the analytic tool is requesting any data, for example, finding the best vendor out of this hunter based on that historical data, then that query will go here to the database and will be reading the data from this hard disk. And then it will be transferring the result sets back into the front end layer. But the aggregation and all, or any complex calculation comes in, that will get processed in here only. In our front end business intelligence layer only. For example, Excel itself. You understand, right? Hello?
Yeah, yeah, yeah. We can understand.
All right. Now, this is where HANA is different. Now, this process takes place like this. The hard disk will be pushing the data into RAM. We know RAM is faster. And then that data will be pushed to processor. Now, the query, whatever query we have, we feed here. That query will go to the processor. Processor has a small memory. We know that. And that memory is called cache memory, which would be very small, like a 4 MB or something. And then we will have a RAM that's also comparatively smaller. Let's say I have a RAM of 4 GB. But my hard disk is having a data that of 100 GB. Now, to find the query's result, that query is here, the processor will request the cache to send the record. Cache will ask the RAM to send the record. RAM will ask the hard disk to send the records. That's in traditional database, RDBMS systems. And here, the database will be supplying all the data, 100, let's assume all the 100 GB data needs to be read. So it will be reading all the 100 GB of data and it will be transferring to RAM. But what is an ideal scenario? In an ideal scenario, it can read only 4 GB of records, right? It can transfer only 4 GB of records because RAM can occupy only 4 GB of data. So every second it will be transferring 4 GB, and ultimately that will take 25 seconds to transfer the records from hard disk to RAM. Then RAM needs to transfer these records to the cache memory, but cache is very fast. And here it will take another, let's assume, since cache is very small, assume it's going to take another 100 seconds. And then the processor will do some processing. Let's say that that will take only 1 second or 2 seconds. So overall, it will take 125 seconds, right? Or more than that in this ideal scenario I'm talking about. Now, I don't want it to lose 125 seconds. I wanted to get the results within much faster time. So is there any way I can get that result in a much faster time? In this same example, if I increase something, if I decrease something, if I do some enhancement or something, is there any way I can get the results much faster? Hello?
Try clustering.
Yeah, so using the in-memory concept should be possible because now the latest RDBMS comes with a lot of in-memory features. So to avoid these barricades, probably the in-memory can be benefited.
Right. So in memory in sense, I need to build a database based on this RAM. That's what you're saying, right?
Yeah. So to give an example, the MemSQL or single store database. So what it does is it will be retrieve a huge amount of data. It processes directly on the memory, and from there it gets processed to the the front-end tool. It can be either BA or any other UI tool.
Okay.
I'm just sharing my view, but I'm not sure if that'll be the
Yeah,
right
yeah,
option.
yeah. I mean, yeah. Let it. Okay. Now, let's say your idea. I mean, the biggest bottleneck here is actually this time. Okay, it's not 25 because in an ideal hard disk, they say we can transfer 3 GB per second, but it's not actually. When you copy something from D drive to C drive, you can see it will be transferring in 25 or 30 MB per second. This is where it's taking 12 hours. So to avoid this, I mean, they come up with a solution. Why can't we increase the RAM to 100 GB? But the problem is we don't have any database based on RAM. We have database based on only hard disk. So they come up with a concept in-memory database. And in general term, we store the data like this. Let's say this is my employee. This is my name. So E01A, E02B, and let's say E03 is C. This is my table, what we see in the monitor. But this data in hard disk, this data will stored like in a sector. Let's say this is my sector. In that sector, it will store this data like this: E01, A, E02, B, E03, C. And this storage is called row store. Every row will get stored first, followed by the next row and next row. The advantage of this model is if a new record comes here, E04 and D, it can easily occupy at the empty space, E04, D. When you read the data, the magnetic disk head has to go and fetch the record one by one from this row-based storage from the sector. So for reading, this idea is wrong. It will consume a lot of time. For writing, it's very good, very fast. And we have one more method of storing the data. That is this. First, E01 I will store. Then the second one in the column I will be storing. E02, E03, E04. Then A, B, C, D like that. And this is called a column storage. Advantage is it can read the data faster. For example, in case if I am reading the record like employee is equal to E03, then the node will first search here. If we don't have an index, first it will search here. Then the needle has to jump to the next E02's position, then to the next one. This is how it works, right? The hard disk works. But the needle need to rotate to the next employee's position. But you see this in columnar storage, the needle doesn't need to rotate much because it's on adjacent fields. But the reading is much faster in this method. But the problem is if a new data comes, E05, E comes, I need to shift all the record from here into the next cell, like a cut and paste. And then I need to occupy an empty space adjacent to the last employee. Then I need to fill it. So writing is very slower. That's why this in-memory brought two ideas, both of them. They say build a table to load all the records for writing purpose and make it raw table. Then build another table, uh, uh, build another table, which should be a column table, and shift the records from raw table to column table. I mean, not all the records in a summarized form. You understand? Hello?
Yeah, yes.
If you have any doubts, you just
It is
ask.
like SandDB. No?
Sorry?
It is like SAN database.
It's on the same database. Yeah, it's on the same database. Like in data warehousing, we have a concept called the staging, right?
Yeah, correct.
Yeah, but in general, data warehousing, we use either a third-party machine for a staging purpose. But in HANA, they say use the same hardware. You use the same HANA for staging as well as for uh, aggregate data. I mean, building the models.
Okay.
I mean, this is very ideal for ELT scenarios, extract, load, and transform scenarios.
Okay.
Yeah, so this is our idea, but this is not the real advantage of HANA, okay? This is just an in-memory concept, but HANA is not just an in-memory database. It's an in-memory computing engine. Now, I'm gonna make a small change here. I'm gonna say amount and 100, 200, 300, 400, 500. Now this is E01. This is E01. Now a query comes to here. Select all the E0 employee E01 and sum of amount. I mean sum of amount of employee 01, and that query will get processed in here. As you know, first any business intelligence query comes, that query will come here, right? And the query, the processor will try to execute the coding, but it cannot. So it will ask, because it needs the record. So it will ask the cache to get the record. Cache will request the RAM to get the data. And RAM is what we have as our database. And this is the data we have in here. Okay, let's say row or column, any database. It doesn't be a matter. Okay. Now, how does this operation works? Does it need to read all the 5 records, or it needs to read only 3 records? Hello? Mayur? Somebody say it. Hello? Are you people able to hear me?
Yeah, I can hear you.
Yeah,
can
I just asked if a query comes from the business intelligence layer, that query comes to the processor, then it comes to the in-memory. And in that scenario, the query is this: select all the amounts of E01. I mean the sum of amount of E01, and this is the table we have in our in-memory. In that case, how many records we need to read from the in-memory, from the database? Do we need to read all the 5 or do we need to read only the 3? Let's say we don't have any index, okay? Let's say we don't have any index. Let's say we don't have any primary key on the table, nothing we have. In that scenario, definitely we need to read all the 5 records, right? We have to read all the 5 records, okay? Now, my biggest question in this case is how many record we need to transfer from the memory to the processor. How many records we need to transfer here? Do we need to transfer after the reading? I came out to know 3 record belongs to that condition. And do we need to transfer all the 3 records, or do we need to transfer only 1 record into the front end, into the business intelligence layer, or into the processor? Or how does it works in RDBMS? Hello? Mayur, are you there?
You can transfer some particular data records using row numbers and writing some complex queries. You don't want to, if you want to filter between records.
So you mean to say it will be transferring only 1 record, or it will be transferring 3 records in this example?
It depends upon the requirement.
Now the query is this, right?
Correct.
Yeah, the query is
Select some. Okay, it will be one record, but what you call saying is that select. You have to do a group by, right?
yeah. I have to do group by. I have to do a
Be one record.
aggregation also. And my question is this: that calculation, that computing, aggregating the data and doing the group by, does it takes place in my database, or does it takes place in database, or does it takes place in front end, in the processor, in the BI layer? Generally that will take place in the BI layer, right?
Correct.
Yeah, this is where HANA is very smart. This entire query will get processed in HANA's database itself. Then it will be transferring only 1 record to the front end. E0, that would be E. Oh, what happened? Yeah. Okay, it will be transferring only 1 record to the front end because it does the aggregation and group by in database itself. Hello?
Yeah.
Yeah. So you got the point, right? That's why. Yeah, that's why we call this in-memory computing engine, because it will be sending only the result sets. It doesn't send the entire raw level data into the front end, into the front end. It just send only the result sets. Now let's continue with this example. This is our system, and this is the front end of any sales order. It happens in the front end. Then we call something like R3 application server. It's a ECC's application engine, ERP, SAP ERP's application engine. Then that data will get loaded into the database. Any data. It could be Oracle, or it could be DB2 or SQL or anything. Then that data we need to transfer from the ERP system. These are the data we have. And these data we need to transfer from ERP to the HANA data warehousing layer, HANA system. HANA has a in-memory area. That's what we call this DB layer. Then it has a presentation area, a studio. Just like any database, a database layer and a studio layer. But HANA is slightly different. It's having a modeling layer. let's assume we brought all the records here into the HANA database, and I need to build a join among these two tables so I can get all the data related to the product and brand. Then in modeling layer, I'll be building a model, a OLAP model, but this is not an OLAP model. This is just a dimension model. It's called attribute view. But what really happens is whatever you built in this modeling layer, it will be sending that code back to the database itself. And that will get stored in a separate DB database. Yeah, technical name, leave the technical names. So that code, the script will be in here. And when a business intelligence layer or any business intelligence Tableau or Power BI or business objects or anything, if it requests the data, that query will get sent to this view. And then it will get processed here, and only the results will be transferred to this business object. And we have three different models here called attribute view, analytic view, and calculation view. Attribute view is like a dimension view. A lot of dimensions we can join together into a single large dimension table, dimension view. Analytic view is like a star schema model where we can have a one central fact table surrounded by a lot of dimension tables or any dimension views. And then we have a calculation view. It's like a multiple, it's a kind of a snowflake model where we can have multiple fact tables.
Yeah, Santosh, my question.
Yeah.
Yeah, Santosh, I'm having a hard deadline. I need to log off right now. So.
Okay. That's fine. That's okay. No problem. Hello. Yeah, that's what this HANA is. It's all about in-memory, and it's an in-memory database, and it's a in-memory data warehousing. And this is how that system look like: a DB layer and a modeling layer, and it's having it doesn't have its own business intelligence layer, but it's having a presentation layer. And these are the ETL technologies where we need to bring the data from the source into the data warehousing. But this HANA, it's having its own ETL layer. It's called EIM, HANA EIM, HANA Enterprise Information Management. And this is how it will look like from ERP or any non-SAP ERP or any legacy machines or anything. We will be using this HANA EAM to transfer the records in real time or in scheduled job. We'll be transferring them into the HANA database. Then we build the models as a part of this HANA data warehousing. Then the data will get transferred to this SAP or business intelligence layer. And this HANA has its own script. It doesn't use SQL. It's called a CE script, calculation engine scripts. And this is how the system will look like. This is its studio front end. It's called studio. Then it can get connected to its database. And we store all the databases here, but we call this in schema. And we have a modeling layer, we call it content. And then we have a ETL layer, it's called the provisioning. And this is just for security and user management. It's just like any ordinary database, but with certain additional properties specifically built for analytical performance, analytical engines. Hello?
Yeah.
You understand? Got an idea?
Yeah.
Yeah. Any queries or something related to this?
Can we see a live? Can you see it in live?
A live system?
Yeah.
Yeah, this is a live system. Not a live means you wanted a real-time system.
Not real-time system. So running a query and how it works.
Yeah. Here you see. Now this is my HANA system. This is my let's say We have an employee table and we have a sales table. Okay. We have an employee table and we have a sales, but this employee table won't work. Let's say products. Okay, let's take this employee table. Let's take only one table. And I need to build a small model based on this, but we may have hundreds of tables that we can do in here. Okay, hold on. Bala?
Yeah,
Yeah, just a moment. My demo system is not working, so I will get that my development. So
sure.
you you know about production, right?
Yeah,
Okay. Now my company has a small. It was having a small issue when they purchase something. They do the scanning, but the scanning, the timing between that entry scanning and moving into that plant, that finished scanning, it was taking too much time. So they asked me to build a real-time business model for this, and this was the model. Where is it? Yeah, this was the model I built for it. I brought the data using a server called SAP SLT, where we can get all the real-time data.
You use a Snowflake or Diamond? Which star?
It's a Snowflake only. It's a Snowflake idea.
Okay.
It's a calculation view. Idea is basically the Snowflake. You are asking about the schema, right?
Correct. Correct.
Yeah, Snowflake, because I involved multiple calculation views here.
Looks
See
like a.
this one? And HANA supports Snowflake only.
Oh, okay.
So based on this model, the data will get processed, and we can get the output. Yeah, it's just a data model.
Yeah.
And I use the server called SLT, so I can get that records from ERP system into not JP1RM, this RWLTP in here. Uh, let's say way back. Way back. ER dat.